Hey everybody, this is James Fakes from Javier Rivera's Fundamentals of Physics class, Section 2 at Full Sail. I'm here to give you my rendition of experiment number 96, string music. It's all about the fundamental physics of string instruments. So let's just start with the big scary formula. It may look a little intimidating, but what it means is if you have 3 of the 4 variables there, you can get the 4th one very easily. Let me give you a real-world demonstration of what this means. The easiest of these 4 variables to get is the length. That's just going to be whatever the length of your actual instrument is, from the bridge to the nut where the string is anchored at either end. The next easiest one to find is going to be the frequency, if you know what pitch you're trying to hit and how you're trying to tune your instrument. There's charts that you can find all over the internet for stuff like that. Here's one I was able to find on Diodario's website. Unit weight's kind of a tricky one. It's a measure of how much mass there is per linear inch of the material. Diodario is helpful enough to list all their unit weights that you can look up knowing the gauge and the material of the strings that you're using. Alright, so now that we have 3 of the 4 variables we need, let's do some math. I know that my guitar's length is always going to be 24 3/4 inches long. That's not going to change. Now right now I have my low string tuned all the way down to B because I'm that cool. That's 61.75 hertz. And I also have been able to look up that the unit weight for this string is 0.000430014 pounds per linear inch. So with those 3 I can find the tension. Now the relevance of this is that it can be very uncomfortable to play a guitar or any string instrument if some of the strings have a lot more tension on them than others. You can use this formula if you know the size of your instrument, how you want to tune, and how you like the feel of your strings to determine the best strings for you to use. This table shows the calculations for all 6 strings on the guitar. The tensions aren't exact, but they're pretty close, and that's all that counts. So what this formula can also tell us is that knowing all the properties of this string, I can add 1.2 pounds of tension onto it to go from 61.75 hertz, or B, up to 65.4 hertz, which is C. Now, the other way I could do that is just shorten the length of it by 1 3/8 inches. And it's the same result. Given that, you can also conclude that there's an inverse relationship between frequency and length of the string. So to recap, tension equals unit weight times the square of the product of 2 times length times frequency all over 386.4. Say that 3 times fast.